For decades, the United States have dominated the skies with an undisputed technological advantage. Stealth. Stealth aircraft such as B-2 Spirit bomber, F-23 Raptor, and F-35 Lightning II fighter represented the apex of military engineering, designed to be practically invisible to enemy radars. This ability to operate without being detected was seen as a decisive letter in any conflict. But this superiority, which has been treated for so long as guaranteed, is now being challenged directly and worryingly. China and Russia claim to have developed technologies that can detect these previously considered invisible aircraft, a direct threat to the American air supremacy doctrine. The key turn in this game began to take shape by 2025 during the Worldwide Radar Detection Exhibition held in Nanjing, China. There, amid dozens of air defense systems, specific equipment caught international attention: the JY-27V radar. Its imposing design, with a wide antenna structure and a high mobility base, indicated that the equipment had been designed to be transported and implemented rapidly in various combat scenarios. But what caught the most attention was the statements of the Chinese engineers. The JY-27V would be able to detect stealth aircraft such as F-22, F-35, and even B-2. It was a bold statement that immediately aroused the interest and the concern of military analysts around the world. The secret behind this supposed revolutionary capacity of the JY-27V is in three main technologies. The first of these is the use of the low-frequency band. Traditionally, the radars that operate in high-frequency bands are more accurate in identifying and tracking targets. However, it is precisely these radars that stealth fighters are designed to deceive. Angled aircraft shapes and radar-absorbent materials work well against short and high-frequency waves, but become much less effective against longer waves typical of the VHF band. Simply put, the longer the wave, the harder for the plane to disappear completely. The second key point of the JY-27V is its very high emission power. To detect a stealth plane, the radar needs to be able to issue such strong signals that even the weaker echoes can be perceived at long distances. This makes even when the plane tries to hide in the electromagnetic background noise, the system can capture small radar signatures that would once be completely scorned by conventional radars. But perhaps the most innovative aspect of JY-27V is in its shipped artificial intelligence. The radar has advanced weak signal processing algorithms. In other words, it is able to filter a huge volume of information, eliminate false positives, and identify, amid the noise, the minimum evidence of the presence of a stealth aircraft. This ability to analyze in real time is what turns a simple low-frequency radar into a real threat to American stealth fighters. However, it is important to make a caveat. The concept of stealth has never meant total invisibility. From the outset, stealth technology has been designed to reduce the likelihood of detection as much as possible, making it difficult to track and obtain a lock-on, that moment when the enemy radar can fix the target precise enough to guide a missile. But radars like JY-27V change that balance. Even partial detection, even intermittent contact, may be enough to force the stealth aircraft to maneuver, give up its original route, or even be engaged by missiles guided by other sensors. Meanwhile, China continues to test and improve its detection systems, and the United States begins to recalibrate its strategies. But China is not the only protagonist in this new chapter of technological war. In the far north of Eurasia, Russia has also made significant advances in low-frequency radars. The NEBO-M system, one of the Russian bets to face American stealth, also promises effective detection against fighters such as F-35 and bombers such as B-2. But before we talk about the power of the radar NEBO-M and the United States' response to all this threat, it is necessary to understand how the development of these new radars is transforming the global scenario of air defense. What is at stake now is not just the ability to detect or not a stealth plane, but the redefinition of the whole balance of power in the skies. While China displayed its JY-27V radar to the world as a symbol of a new technological level, Russia worked more discreetly but no less ambitious. The NEBO-M system, one of the jewels of Russian engineering, represents Moscow's response to the challenge of detecting stealth. Unlike traditional radars, NEBO-M is a multifunctional and modular system that can operate in several frequency bands at the same time, including VHF, L-band, and X-band. This flexibility makes it one of the most feared systems in Russian arsenal, simply because it can combine the strengths of each frequency range to track, identify and track targets that are difficult to detect. NEBO-M also stands out for its ability to integrate multiple sensors and radars into one network. In practice, this means that radar stations spread across different regions can share real-time information, creating a much more complete air situation. If a low-frequency radar detects a suspicious echo, the other high-frequency radars of the network can immediately concentrate their beams in that sector, increasing the chances of confirmation and continuous tracking. This concept of sensor fusion is something that the United States also use in its own defense systems, but Russia's ability to apply this to multiple bands with wide territorial coverage is a cause for worry in Washington. Like the Chinese JY-27V, NBOM supports strongly on advanced signal processing algorithms. But there is an important difference. Russia has decades of experience in the operation of low-frequency radars, accumulated since the Cold War. This means that their operators and engineers are already used to working with the specific challenges of this type of detection, such as atmospheric interference and the high rate of false positives. The accumulated know-how allows you to operate more accurately and efficiently, according to the Russians. Given this new reality, the United States was not stopped. Lockheed Martin, the leading manufacturer of F-22 and F-35 fighters, is already developing update packages for these aircraft, with the aim of raising their stealing capabilities to a new level. These updates include from improvements in radar-absorbent coatings to adjustments in external surface design and the use of more sophisticated electronic war technologies. The idea is to create what analysts call a stealth plus, a kind of intermediate version between current aircraft and future sixth-generation fighters. In addition, Pentagon has also invested heavily in enemy air defense suppression operations, known as Suppression of Enemy Air Defenses, SEAD. The purpose of these missions is to neutralize enemy radars before they can effectively track stealth fighters. This can be done through attacks with anti-arresters, kamikaze drones, or even cyber war, disabling remotely detection systems. But even with all these efforts, there is a question that hangs in the air. Are these new Chinese and Russian radars really as effective as their manufacturers say? To date, all available information comes from official sources of these two countries. There are no reports of real combat in which the JY-27V or NEBO-M actually have been able to track and overthrow an American stealth. This whole discussion revolves around simulations, controlled field tests, and, of course, a good deal of military propaganda. Defense experts around the world remain divided. Some believe that detection capacity has actually advanced a lot, and that the days of invulnerability of stealth fighters are told. Others, however, argue that the physical limitations of stealth technology have been known for decades, and that new radars only expand the detection zone without offering a leap as large as advertising suggests. A curious point in this story is that, even with all the fuss over its new detection capabilities, China continues to invest heavily in the development of its own stealth aircraft. The J-20 fighter, for example, is the pride of Chinese military aviation, focusing precisely on stealth. If the Chinese radars were really as effective as it was disclosed, why would they continue to spend billions of dollars on airplanes that would theoretically be obsolete in the face of these new radar technologies? This contradiction raises suspicions. Many analysts see in Chinese and Russian statements a strong component of psychological war. The idea would be to plant doubt in the United States armed forces, forcing them to spend more, revise their strategies, and, above all, operating more cautiously in areas potentially covered by these new radars. Psychological pressure is also part of the modern war. When an F-35 pilot takes off for a mission and knows that there is a possibility, even small, of being detected, he inevitably adopts a more defensive posture. This affects the execution of the mission, the exposure time, and even the approach routes. The simple fear of being seen already changes the whole game. But, like every technology race, the United States' response goes beyond simple updates in existing fighters. Behind the scenes, new generation programs are being accelerated. The so-called sixth generation of combat aircraft promises a new leap, both in stealth and electronic war and situational consciousness. The Next Generation Air Dominance, NGAD project, for example, is treated as an absolute priority by the Pentagon. But will all this be enough? And most importantly, stealth technology still has a future in a world where low-frequency radars and artificial intelligence algorithms seem to be reaching what was once impossible. These are the questions that military and defense engineers try to answer now, while the air domain dispute intensifies. As the technological dispute between China, Russia, and the United States intensifies, the concept of air invisibility undergoes deep transformation. If before the idea of a stealth plane was synonymous with guaranteed superiority, now the reality is much more complex and uncertain. Both Beijing and Moscow continues to proudly publicize the advances of their radar systems, insisting that their detection networks are able to identify, track, and, if necessary, slaughter stealing aircraft with increasing effectiveness. And the center of this new narrative remains the low-frequency radars, such as Chinese JY-27V and Russian Nebo-M, which together represent a real threat to the traditional U.S. air war concept. While technical specifications continue to be carefully controlled on both sides, it is known that the strategy is now the integration of multiple sensors into overlapping layer surveillance networks. This is no longer a single radar trying to hunt a lonely stealth fighter. What is forming is a true detection ecosystem, where satellites, land radars, infrared sensors, and even electronic listening systems work together, exchanging real-time information to identify any anomaly in airspace. A stealth aircraft may even escape an isolated radar, but when dozens of sensors are looking at the same sky, different angles and at different frequencies, the safety margin for U.S. pilots decreases significantly. On the other hand, the United States is far from accepting this new vulnerability without reacting. In addition to the updates on existing aircraft and the development of sixth-generation fighters, there is a growing investment in electronic overshadow technologies. The F-35 and the F-22, for example, have already begun to receive improvements in electronic war systems, allowing you to create false targets in enemy radars or even confuse the algorithms responsible for signal analysis. This means that even if a low-frequency radar detects something, it may not know exactly what you are seeing. It is an illusion game, where American technology tries to transform the data collected by the opposing radars into pure noise, full of fake clues. In addition, the operational doctrine of U.S. Air Forces is also changing. The focus is now on network, with greater cooperation between different platforms. Manned planes, autonomous drones, long-range missiles, and even satellites of recognition operating in synchronization, all with the objective of reducing exposure time, increasing lethality, and minimizing the chances of detection before the mission is accomplished. The air war, which once looked like a duel between fighters, has now become an electronic warboard, artificial intelligence, and superiority of information. However, even with all these contracted, the truth is that vulnerability has increased. The mere fact that China and Russia have managed to advance both in the field of detection already forced the United States to rethink their entire stealth aircraft use strategy. No technology is infallible, and with every advance in the field of invisibility, a new generation of sensors always trying to cancel this advantage. The cycle is eternal. For each improvement in stealth, a new generation of radars is born, and for each more powerful radar, a new layer of protection and disguise emerges. Outside the technical field, there is also the question of the credibility of Chinese and Russian allegations. To date, no Western Air Force has officially confirmed that it has been detected or tracked by these new radars under real conditions of combat. The demonstrations made so far have occurred in controlled environments, during exercise or in laboratory tests. This leaves a margin of huge uncertainty. After all, it is not uncommon for technologies presented with large fuss at military fairs end up not having the expected performance in real situations. On the other hand, the mere fact that the United States is investing billions in new updates and developing new stealth concepts already shows that the Pentagon takes the threat very seriously. No one spends so much money on a problem that doesn't consider it real. This alone indicates that even if Chinese and Russian radars have not yet shown practical results in combat, their potential is already changing American strategic planning. The Chinese contradiction also remains a central piece in this puzzle. If the JY-27V were really able to eliminate stealth efficacy, why then continue the development of fighters like J-20 and the future J-31? Why spend so much on stealing coatings and stealth design if, in practice, Would Chinese radars themselves able to neutralize these characteristics? The answer may be precisely in uncertainty. Both China and Russia know that despite the advances, detecting a stealth aircraft in real war conditions remains a gigantic challenge. Deep down, what we have is an action and reaction cycle, typical of military technological disputes. With each advance in detection, a new generation of aircraft with even more advanced stealth improvements will come. And with each new stealth hunt, new radars, new sensor networks, new algorithms will emerge. Technological war never ends. It just changes shape. What is clear is that the skies are becoming an increasingly complex battlefield, where invisibility is no longer a guarantee, but a temporary advantage, subject to being broken at any time. For American pilots who today fly in F-22 and F-35, the age of absolute invisibility may be coming to an end. And the future of the air war will be decided not only for those who can hide better, but for those who can see first.